So welcome everybody to this latest A2 video on 160 maths, and in this video we'll be continuing from binomial expansion, but this time we'll be looking with when you've got negative and fractional powers. So as we learnt at AS level, that in order for us to expand a bracket that's been risen to a power, a positive power, such that we can use this formula. Now this formula is given to us in the formula book, so we don't need to worry about remembering, and let's just make a little note of that just in case. But it is one of these formulas that is given formula book. And obviously in previous examples, all we've ever worked with is with positive powers of n. So in terms of if we want to expand 1 plus x to the power of 5, then here what we've got is substituting this in, we've got n equals 5 and x equals x. Now the reason why I'm writing x equals x is because if I did have a coefficient of x that wasn't 1, then what I'd need to do is just put brackets around that and obviously raise the coefficient to the power that is in the position of its formula. So for example, if I had 1 plus 2x, then here x would equal 2x, and then what I did, rather than writing 5x, I'd write 5 and then 2x, and then 5 times 4 divided by 2, that'll be 10, and then it'll be 2x squared, and obviously that then becomes 40x squared, etc. And obviously simplifying that then gives me my expansion. Now in the video where we covered binomial expansion at AS level, there are several ways in which you can easily do this without using the formula. However, when we move on to this particular level where we're potentially dealing with negative and fractional powers, then using this formula is going to be a must. So if you didn't use it before, unfortunately you're going to have to learn how to use it, and if you did use it before, well, you're not learning anything new. Now the key thing to remember is that, however, if n is not a positive integer, then the expansion will not terminate. So just like we did here when we had positive powers, and here we've got positive power of 5, then the highest power of x is going to be the 5. So whatever n is, that's going to be the highest power. However, when we're dealing with negative, or when n is not a positive integer, I should say, then the expansion is not going to terminate, and it's only going to be valid between the values of where x is between 1 and -1, or the mod of 1 if you've looked at modulus. Now where this tends to come from is, obviously if you think back to more the applied questioning for binomial expansion, is when you're asked to work out, let's say 1 plus x to the power of 10, and then you have your expansion, and then you may then get asked to work out what's 1.001 to the power of 10, and you need to work that out. Well, using the expansion, all you need to do is make 1 plus x equal to 1.001, and you realise that x is going to equal 0.001. And then from this, you then substitute x equals 0.001 into your binomial expansion, and you would therefore have an answer for that. Now, obviously, this type of method, when you're dealing with non-positive n values, is only valid when x is between -1 and 1. And so you tend to find certain questions will ask you what the values of x that make the expansion valid, and which we'll come on to that when we look at some example questions. So let's have a look at our first example. So the first question says, obtain the first 4 terms of the expansion of 1 over 1 plus x. Now in terms of solution for this, let's just write down what we're going to end up with. So the solution, the first thing I want to do is convert it into indice form. So I've got 1 plus x, so how I'm going to write that is 1 plus x to the power of -1. And that should be always something that you want them wanting to do. Now, another thing obviously forward thinking is that before we move on to the binomial expansion, so let me just write little notes. So what we've done is convert into indices. And then the next check you want to do is make sure the bracket starts with +1. Now again, for this it's not really an issue because we're starting with a positive 1, and so it doesn't really matter about the sort of sign of x. That will come on to that in a later example, but you need to make sure that you always start with +1, which for these first two, with the examples covered in this video, it will always be the case. So for then, what we then need to do is get our variables. So for this, let's just do some hashtagging so you know what my steps are. So that's number 1. Number 2 is then use the formula. So here we've got n equals -1. So what I need to do is substitute n equals -1, and I only want the first 4 elements of the formula needed. So it's always worth writing down the first first 4 elements of this formula. So I've got 1 plus nx plus n minus 1 over 2 factorial of x squared plus n minus 1 n minus 2 over 3 factorial, and it's x cubed. Now from this, as you can see, we've only got a single x, so I don't need to worry about this element here. That's just going to be x, and so all I need to then do is substitute the numbers in. So here I've got n equals -1, so it's going to be 1 plus, now I always like to use brackets wherever I can. It just makes it a lot easier. So here I've got -1 minus 2 over 2 factorial, and that's x squared, plus -1 minus 2 minus 3 over 3 factorial, that's x cubed. Now in terms of completing this, what we then need to do is, I would recommend always reaching for your calculator and then working through the numerical part. Now what I mean by the numerical part is this bit here. In terms of the x, I would always do that yourself mentally. It just saves you from making any silly mistakes, which I see a lot of students do. And then doing just that, what do we end up with? Well, we end up with 1 minus x positive 1, so it's going to be x squared, minus -1, which is going to give me minus x cubed, and there is my final answer. Now in terms of certain extensions, if I wanted to work out what it was valid for, so as an extension, so you will also need to quote the values of which, or of x, which this is valid for. So in order to do this, the best way of doing that, I can see that I've got quite a few L's and I's in there, so let's just edit that. So for this we've got 1, if I took the original questions, let's just change this colour, let's go for yellow. So here I've got 1 plus x to the -1. Now to work out the range of which is valid for, all I need to do is basically take this element here, this coefficient, which is 1. I then take the constant coefficient and have that here, have them all being divided by each other, and then have the mod of both of those, and that is going to be less or equal to 1. And then if I then go on to solve this, all it then becomes then is basically, and what I then need to do is simplify this, and if I've got an x, well I should have, that's what one thing I forgot, is the x, got 1x, simplify and make x subject, which in this case is pretty simple because all I'm going to end up with is that. So that this here is a range of x values in which this expansion is going to be valid for. Now again, it's hard to kind of understand because we're dealing with ones, and this initial expansion that we've done is pretty basic because it's 1 plus x, but when we start moving on to more complicated expansions, hopefully this type of method will make sense and I will go over it as well. So let's have a look at our second example. So this second example says, and let me just do a little bit of editing that I've spotted. So it says that given that x is so small that x to the power 4 and higher powers of x can be neglected, show that the square root of 1 plus 4x is approximately 1 plus 2x minus 2x squared plus 4x cubed, giving the values of x for which the expansion is valid. So first of all, let's start off by rewriting, as we did before, writing the question using our rules of indices. So for that then, what we need to do is get a different colour pen. So here for the solution, we've got the square root of 1 plus 4x, and that can be written as 1 plus 4x to the power of a half. Now for this I only need to go up to x cubed, so the next thing I then need to do is quote the formula. So we've got 1 plus nx plus n 1 minus n over 2 factorial plus n minus 1 n minus 2 over 3 factorial. I forgot my x squared. It's my x cubed. So that's as far as I need to go. So in other words, the first 4 terms. So substituting numbers in, just exactly how I did before. So again, it's maybe worth noting that n equals a half in this particular example, and x equals 4x. So substituting everything into the formula, what I get is I get that 1 plus 4x to the power of a half is approximately 1 plus, and it's going to be a half, and then 4x plus a half. Take away 1 is minus a half over 2 factorial. It's going to be 4x squared plus a half minus another half minus 3 over 2 over 3 factorial, and it's 4x cubed. Now from this, what we can then do is then go on to simplify all of this. So here what we've got is I've got 1 plus, and then the first one is going to be half times 4, which is 2x. And for the next one, I'm going to end up with, well, if I simplify, do the number bit on my calculator, then this then becomes minus 1/8. And 4x squared is going to be 16x squared. Plus, again, if I do all of this bit on my calculator, I end up with positive 4. And 4x cubed is going to be 64x cubed. So then all I then need to do is simplify all of this, in which what I get is 1 plus 2x minus 2x squared plus 4x cubed. That then continues. Now in terms of the range of which it's valid, let's just get a different colour pen, we'll see. So for the validity, what we've got is I've got 1 plus 4x to the power of a half. Now the half doesn't make a difference, so we don't need to worry about that. So for this, what I've got is I've got this bit which goes as my numerator. I then got this bit which goes as my denominator, and that is all in the mod of less than 1. Now from this, what I then want to do is I want to make x the subject in this. So treat it like you're solving an equation. So what this then becomes is 4 on there, like that. And then we've got 4x less than 1. And what I've then got is that x is between a quarter. Now this is the same as minus a quarter x and a quarter. Now if you've not done modulus, then you can write your answer like this. If you have done modulus, which at the end of the course you will have, then you write your answer like that, but that would be absolutely fine.